Hello, this is Chad Payne with Lens Software. In this video on RTX Development, we're going to look at the calculation function. In the last video, I looked at creating and managing parameters. In the next video, I'll look at the drawing function. But for now, we're going to focus on how to calculate. In this case, we're calculating moving average. So we have a single array. The input is going to be the closing price. And we're going to do a simple moving average on the closing price of each bar. So you'll see each dot, I've got a 13 period moving average here, so each dot is just a simple moving average of the close of that bar and the 12 previous closes. So it's just a simple moving average. So let's dig into the calc function. So this is the calc function in its entirety here for the moving average. And you see at the very top we're grabbing our user data or our parameters. And for the calc function, the only parameter we'll need is the period, which is 13 that we looked at earlier, the period of our moving average. Now the key lines for grabbing the parameters, this line, and I've just moved them down here so we can look at them all together, and this line. So what you're doing, you're allocating the user data. If it's already allocated, it'll just grab it. So you're generally just going to call alloc user data to grab the user data. It'll allocate it if it hasn't already been allocated for that instance of the indicator. And the spec size, and the reason I do this, I include a section of my parameters for runtime variables. Those are variables that I need to calculate at runtime and pass between the calc function and the draw function and the mouse function. We'll get into a lot of examples of that, but this tells it to exclude anything from runtime on, and don't grab those when you're grabbing my parameters, my permanent or persistent parameters. So that's the reason for grabbing this spec size, which excludes the runtime parameters. And then it grabs this get parameter, and you can just you really don't need to know all this. You can use this exact template every time. The only thing you'll need to change, if you do change the first parameter in your list of parameters, let's go look at that. If you do change this first parameter, you'll need to go through the code and just search for what it was before S period and change it to whatever the name of your first parameter is. There'll be about 4 or 5 places through the CPP file that you'll need to replace with your first parameter. That's all you'll have to do. So this get parameters will load the parameters into the puser function. And you'll look down here, we reference the S period. At that point we can reference S period, and I've just put it into a local variable. So in just about every function that you'll need your user data, any of your parameters, this is the process you'll use. You know, the draw function, the mouse function, and so forth, when you need to access and or store any of your persistent parameters. And on these two lines you'll see that we access the bar data. We got the close, the open, the high, and the low, and you'll see how you do that. You declare an RT array, and then you send in the proper enumeration. If you go to irtsdk.h, you can see the enumerations that are available. This one gives you the average of the open, high, low, close. You got the open, the high, so a lot of different pieces of data you can extract from the bar. And I actually don't need most of these. I just need the close, but I'm just showing you, for example, you can grab the open this way, the high, the low, the time of each bar, date and time, and the volume of each bar. Now on this line is specify my output array. And if I look back at irtsdk.h, you'll see that I can have up to 42 persistent floating point output arrays. I only need one for my simple moving average here, but you could, if you needed 2, what you would do is simply declare fout2. So I would put fout2 here and call that maybe output 2 or whatever you want to name the array. Now these are persistent. They're not allocated every time we calc or recalc. They are retained and maintained efficiently by InvestorRT. And these may store arrays that you draw, or they may just store temporary calculations that you need to efficiently recalc your indicator. But you have access to up to 42 of these. And if you do increase the number of arrays you're using, you must remember to come up to the create extension function and increase that number here. So if I was going to use a second array, I would need to enter a value of 2 here in the set array count function in create extension. Now the I start bar is sent in. Now that's the bar that Investor RT wants you to start your calculation. If it's a full calculation, let's say you're just now first adding the indicator to a chart, or you're just opening the chart that has the indicator, it's going to be a full calculation. I start bar is going to come in as 0. That's how you know that it's a full calc versus just an efficient recalc. Otherwise, I start bar will probably be the next to the last bar in the chart. So it'll be not the last bar, but the next to the last bar, and you can start there and do an efficient recalculation from there. I often do this in my declaration. I declare a B recalc, a Boolean, and I just check to see if I start bar is greater than 0, and if it is, then I know it's a recalc, and I can act accordingly there. So in this area here, I'm simply computing my output 1 array, my moving average. In this section, I'm checking to see if it's a full calc. If not recalc, that means it's a full calc, and since I was set to I start bar, I know it's 0. So I'm just going to initialize my value on the first bar in the chart to the close of the first bar in the chart, just initializing it there, and then incrementing I, and then moving down here to my calculation of each bar and the moving average on each bar. So on a full calc, I'll just initialize that first value, and then I'll increment this to 1, and I'll start with I equals 1 in this for loop. On a recalc, I'll already be probably, this is a number of elements in the CL, the close array. Okay, that's the number of bars in your chart. You can rely on that value to be the number of bars in your chart. So you want to be able, you can access up to CL count -1, okay, because it starts at 0, and the last bar, the rightmost live bar, is going to be CL.count -1, the offset within the array. Whether that be the output 1 array, your close array, your open array, any of those arrays, you can access from 0 up to CL.count -1. So on a recalc, it's going to start basically from CL.count -2, so it's just going to recalculate efficiently the last 2 bars. A very quick calculation the way I've done this. And a little trick you can do for simple moving averages, I can take my moving average on the previous bar and multiply it by the period, and then subtract out the, okay, I actually just found a bug in this code, so this was not accurate. This should have been CL. So you can take the moving average value on the previous bar, multiply it times the period, subtract out, in this case, the close bar, period bars back. So you're removing that value, and then you're bringing in the latest close on the current bar, and then divide that by the period. So that's a little trick you can use to very efficiently calculate the moving average. If you already have the moving average on the previous bar, you can just back out the close period bars back, add in the new one, then divide that by the period, instead of having to add up 13 values again and then divide by the period. So that's the calculation function in a nutshell. We'll get into some more complex concepts within calculations, such as looking at volume at price, in future videos. So I hope you found this video helpful. If you have anything specific within the calculation function that you're trying to do and struggling with, please email support@lensoft.com, and I'll make it a priority to get that into our RTX development